Now we're looking at factoring a perfect square trinomial and a difference of squares. And here are some pink sheets that I'm simply looking to get rid of. Alright, so for this lesson, you may recall that some lessons ago we had taken a look at special products. Well, we're going to use that knowledge of special products to help us in factoring. So in other words, when we had these types of expressions, right, we were learning how to expand, right? How to expand those, and we would end up with these, right? Well, now we're going backwards since we're factoring, so we're gonna learn how to recognize these patterns. Alright, we're gonna learn how to recognize these patterns, the patterns of perfect square trinomials, right? And if we can recognize these when we see quadratic expressions, they can help us to factor in faster, quicker ways, more efficient, right? So same thing, we'll be looking at difference of squares patterns, right, in quadratic equations. All right. So, but before we continue on with this, I want to point out that I think it's important for us to recall our perfect squares, right? So 1 square, 2 square, 3 square, etc. 1, 4, 9, 16, 25, etc., etc. I think knowing your perfect squares up to 12, it's good. If you know beyond that, that's great. That's as far as I could get. Okay, so let's start looking at some examples here. Let's start looking at some examples and see if we can recognize these patterns, right? So you have example 1 here, right? So normally, to tell you the truth, when I look at these, I don't necessarily I'm not necessarily able to tell immediately whether they're perfect squares or difference of squares, right? Because sometimes they may look like they're difference of squares, and they turn out not to be, right? But in this case, all right, we know that 25, we know that that is a perfect square, and then we know we have 1x squared here, or x squared. That's also a perfect square. So, and there's a minus sign in between them, so we know we're dealing with a difference of squares. So I'll just place the pattern here at the top so that we can use it as a reference. Okay, so if we're given a question like this and we're asked to factor it, right, we know that this is a perfect square, we know that's a perfect square, this is a difference of squares. So if we look at the pattern, right, a squared minus b squared, a plus b, right, so we know that our a value would be, right, the x, and our b value will be the 5. So if we simply follow this pattern, all we have to do is, well, we write a here, b over here, and we simply put a positive and negative sign, and then we have factored this equation. We're done, right? So the important thing is recognizing the patterns, right? Let's start looking at another example here. Right, I'll go a little faster here. Maybe I should not have made so much space, but here it is. We have 4 here at the bottom. 4 minus 9 w squared. Alright, so just like factoring, actually, so we first, is there a common factor among these terms? No. Is it a simple trinomial or a complex trinomial? I would say, well, it's a complex trinomial, right? Now, is it a perfect square or a difference of squares? Well, it looks like it's a difference of squares, and let's check. Okay, that's a perfect square for 9w squared. This is a perfect square. Yes. So this, the answer to this would be, right? We're looking at 2 plus minus, and then we would have here 3w. All right, and right. So once again, the important thing is recognizing the patterns, right? Recognizing the patterns. Let's look at one more example. Right? In this example, we have 2 variables, r and s, right? So once again, is this a difference of squares? Well, let's step back a little bit. First, Is there a common factor among the terms? No. Is it a simple trinomial or a complex trinomial? Well, let's treat this as our ax square value, so it's a complex trinomial, right? Is it a perfect square or a difference of squares? Well, it's a difference of squares, right? Okay, because we know that 25 is a perfect square, r square is a perfect square, right? 36 is a perfect square, s square is a perfect square. So, same thing, right? As long as we recognize a and b, right? We know we're going to have a plus, a minus. So here, for this, the expression, for the a expression, this is 5r. 5r. For this expression, 6s, 6s, and then the difference of squares pattern, plus and minus. Alright? Okay, so continue practicing these, and we'll take up the rest of the examples.